How energy learned to hide. Energy was supposed to be obvious. You could see it move. You could feel it work. But physics eventually uncovered a disturbing truth. Most energy does not announce itself. It hides. It slips between forms, disguises its presence, and leaves behind effects without revealing where it went. To understand why this matters today, we need to revisit how energy was first imagined. Energy was motion, heat, force, something active and visible. If work was done, energy had to be somewhere you could point to. Lost energy felt like a mistake. This view worked until systems became complex. Machines lost efficiency. Motion faded. Heat spread and vanished into surroundings. Energy seemed to disappear. But careful accounting revealed something unsettling. Nothing was missing. It was just no longer accessible. The first clue came from heat. Once energy spread into random motion, it could no longer be fully recovered. The total remained, but its usefulness vanished. Energy was conserved, yet functionally lost. This forced a new understanding. Energy could exist in forms that resisted extraction, locked into disorder, trapped in configurations that could not be reversed. Energy had not gone anywhere. It had learned how to hide. Once this idea took hold, energy stopped being a simple quantity. It became contextual, present everywhere, but only sometimes usable. And that distinction would reshape how physics understood loss, efficiency, and the arrow of time itself. At first, this hidden energy felt like a technical nuisance, an engineering problem, not a fundamental issue. Machines wasted heat. Engines lost efficiency. Friction stole useful motion. These seemed like practical limitations, not deep truths. But as systems were studied more closely, a pattern emerged. Energy always moved toward states where it was harder to organize. Heat flowed from hot to cold. Order dissolved into randomness. The universe favored spread over concentration. This behavior revealed a deeper rule. Energy could be conserved while still becoming unavailable for work. Usefulness and existence were not the same thing. Energy did not vanish. It degraded. This distinction reframed loss entirely. Failure was not about missing energy. It was about energy becoming trapped in forms that resisted control. Random motion, dispersed heat, configurations too complex to reverse. As understanding grew, this idea expanded beyond machines. It applied to stars burning fuel, to biological systems aging, to information being erased. Energy hid itself in disorder, and retrieving it required more energy than it was worth. This was not a flaw in design. It was a rule of the universe. Energy naturally flowed toward hiding places, and once there, it rarely returned. What looked like inefficiency was actually inevitability. The universe was not losing energy. It was redistributing it into forms that humans could no longer easily reach. The conflict sharpened when scientists realized this hiding was not accidental. It was directional. Once energy spread into disorder, it did not spontaneously regroup. Broken patterns did not heal themselves. Heat did not flow backward on its own. This introduced a deep asymmetry into physics. The fundamental laws allowed reversibility, but reality did not behave that way. Time itself seemed to favor one direction. Forward meant more hidden energy. Backward required impossible coordination. This buildup revealed why certain processes feel irreversible. A glass shatters easily, but never reassembles. A battery drains, but does not recharge itself. These are not coincidences. They are consequences of energy slipping into inaccessible forms. As this understanding matured, it reshaped how entropy was viewed. Disorder was not chaos. It was accounting, a measure of how thoroughly energy had hidden itself. High entropy meant energy was still present, but locked away behind overwhelming complexity. Emotionally, this was unsettling. It meant that decay was not a failure of maintenance. It was a feature of existence. Systems aged because energy dispersed. Structures collapsed because usable energy bled into noise. By this point, energy felt less like a resource and more like a fugitive, always conserved, always present, but increasingly unreachable. And that realization was leading toward a final conclusion about time, loss, and inevitability itself. The climax arrives with a sobering truth. Energy does not disappear. It retires. Once energy hides, it still exists, but it no longer works for you. The universe keeps perfect accounts, but it does not guarantee usefulness. Conservation ensures balance. Entropy decides access. This understanding reshaped science and technology. It set hard limits on engines, computation, and even life itself. It explained why perpetual motion is impossible, why efficiency has ceilings, why time feels like it moves forward. More deeply, it reshaped perspective. Every process that creates order must export disorder elsewhere. Progress is a cost. Structure borrows against the future by hiding energy in the background. Today, this insight quietly governs everything from power plants to biology. Every heartbeat, every thought, every machine run relies on temporarily accessible energy, slipping gradually into hiding. Energy learned to hide, and in doing so, it taught us something uncomfortable. The universe does not forbid change. It makes it expensive. So what do you think? Are we repeating the same mistake again?